Sorry. Okay, away we go, I guess. So basically, hold on, I'm having technical problems again. This is so much fun. This is the golden hammer, which if you haven't heard the term, is just basically essentially if all you know is a hammer, everything looks like a screw or everything looks like a nail. I started in a completely different field. Um, Accidentally became a developer. Accidentally started doing some SQL stuff, and the more I learned about SQL, the more I realized that the things I was doing before I really knew SQL were probably not the best way to do it. So it's been definitely a path of pretty strong growth since then. Um, first thing that I learned, most definitely, do not ever test anything in a production system, because you will definitely regret um, doing that. Bad things happen even when they're not supposed to or they're not allowed to. Things break. The second thing I learned doing SQL, we had the requirement to do some reporting. And the first thing we started doing is, well, we've already got our data set up, so we'll just report from our main system, which that was okay at first. But as we grew and got well over 10 million records, well over 40 million records, it really started slowing things down when people were running more reports. So we learned very quickly to go ahead, and it's easy to spin off a reporting instance of the database and do reporting from there. That way your actual users are not being impacted by people just simply running reports. The next thing I learned when I started doing a little bit more administration side of it was that and it's kind of more of a general thing too, is that backups are absolutely worthless if you don't really test them. You can take backups all day. You can have months worth of backups, but if you had a problem 3 months ago and you just continue to back up that problem and you decide you need to restore something from last week, it doesn't do you any good if the problem's already there. Or if the backup simply doesn't work, because I've had that too. Or even worse, most recently I had a system where I thought I'd set up backups. It turns out I didn't have any backups of my databases. My database. I needed to restore it. There was no backup to restore except for the very first one that I took. So unfortunately, I was just spinning up this database, but I didn't want to have to do all that work again. So I went to my storage person, my virtual machine and storage person, asked them, hey, can we just restore from this image, I guess, from yesterday? And so he said, oh, yeah, sure, no problem. That's when he found out that he wasn't running backups on that PC there. So we had to both of us had to do all that work. And then we both learned if we tested our backups, we definitely would have seen that. We definitely have a backup solution on that now. But that's a very, very, very hard lesson to learn. And then again, with databases, it's just like any other programming things. There's really hard and fast rules for everything that are always true. A lot of times, sometimes the things that are definitely true aren't. So you just have to kind of play it by the situation. Except for the only rule is don't test in production. I mean, that really shouldn't need to be said. And again, if you've ever done it, you will find out why. So now that I've kind of covered those basic rules, what are we going to talk about here today? What is SQL? What are some of the bad habits that I got into? And then there's really when I first set this up, I thought this was I could not figure out how I was going to be able to talk for an entire hour about this stuff until I started writing out my notes, and I realized, oh my God, how am I only going to talk for an hour on this stuff? So there is a lot more than I thought once you start digging into it, I guess. So I guess we'll start with some basic stuff. First off, what is SQL or SQL? And there's many. Really, the definitions are great. Domain-specific language used in programming to design to manage data held in a relational database, and that's a lot of stuff to say. Essentially, it's a way to talk to your data store, I guess. And again, do you pronounce it SQL? Do you pronounce it SQL? Yes. Nothing is really wrong with either one. That's pretty much is it JSON or JSON or JSON? Depends on, or JSON, depending on how you want to say it. Technically, SQL is the more correct one now, but it doesn't really matter. I say SQL Server when I talk about Microsoft. I say MySQL when I talk about MySQL. It really depends. So again, it's mainly the language that you use to talk to your database. It's a standard. The base of SQL is a standard. So you have a you have a standard that will be I guess the baseline, and then each company or each proprietary platform like Microsoft's T-SQL or Oracle's PL/SQL or MySQL, they all have their own little additional flavors that they've added to it. So those are the things that kind of, just like anything, they kind of get off standards, but they still at their base are the same thing. One of the biggest things that I had to realize, I guess, when I started working with it, though, is that SQL itself doesn't really work like most other programming languages. And in most programming languages, you say, this is how I want to do something. If you want to make a sandwich, you say, I get the bread out of the cupboard and I put my get the peanut butter out and I get a knife out of the drawer, put the peanut, you do all that. But with SQL, you just say, I want a peanut butter and jelly sandwich. And SQL knows it knows that it's got all those things. And then it figures out itself how to put all those things together and then give you back what you're asking for. It's a pretty smart system on the back end. They just keep getting smarter and smarter on everything, every iteration that they go through. But they're only as smart as what you tell them. They're very easy to be led astray as far as what they think they have. They keep up with their internals, with the data that they have, but they can be given bad information, and then with that bad information, they can give you bad results, which just kind of keeps perpetuating the problem. So the big thing is that they're very, very complex. The thing that, again, when I started working with databases, when I started working with SQL, it became a much bigger task than I realized it was. It's easy to learn enough to get the job done, but then once you start really digging into it, you realize that there's a lot more that can be done. There's a lot more things that may be done. There were a lot of things that I was doing in my code that I could have pushed down closer to their source inside the SQL. A database isn't just a place to store your data. Most modern ones have really robust security systems that can be used to really lock down data, to lock down different pieces of the database, to only allow access to the people that really need that information. And it can also, a lot of them also have ability to do some pretty heavy encryption on them, so that if somebody does happen to get a hold of your database, which is quite common right now, they're not really going to get anything that they can read. So that's definitely very helpful. They also have the ability to encrypt the data both at rest and in transit, which is, again, another very good thing that keeps somebody from snooping on any connections from somebody that is authorized to get that information. They also have the ability, again, to backups and restores, which are very important to know about. I guess at the most basic though, most SQL is simply just the creates, reads, updates, and deletes. It's just CRUD work, so it's very simple. It's very simple to get into to start doing, and I guess that's where I really learned some of my bad habits, because when I worked on things on smaller databases that only had a few hundred rows, some of my some of my queries were very simple, very easy, and they worked just fine when I had to iterate over a few hundred rows. It didn't really matter that the way that I was doing it might take 10 or 15 milliseconds longer than something than the right way. You don't notice that 10 or 15 milliseconds when you're doing a few hundred rows, but when you're doing millions of rows, that 10 or 15 seconds per row kind of adds up quite a bit, pretty fast. So what are some of the bad habits, I guess, that I really got into? One of the first ones, probably one of the most common ones, is select star. I think probably everybody has used select star because it's easy. You don't have to type out all the names of the columns. You don't have to think about them. You don't have to remember them. You just type it, and the database will figure out what all the column names are. The problem with that is that, first of all, a lot of times people will only need 2 or 3 columns in their data or in their program, but they'll select star just, again, because it's easy. That can lead to a lot of data. The database does more work because it has to select. If you need 2 columns and your table is 200 columns wide, it'll select all 200 columns of that data and then send them back. So that relates to more work from the database having to do a lot harder work to get all those fields together, which when it transfers that work, that's a lot more data that it has to send over your network. So it's going to stress that entire network. And then once it comes back to your application, now your application says, well, I have this big old pool of data. All I need is 2 columns. And then now your application has to sort through all that data to pull those 2 columns out. The other bad thing that can happen is that it can cause your database to use an incorrect index because there may be, if your database sees that you're pulling all these rows, you may have a specific index saying that if I need all these records that happened in January from user 12, if you select everything, then it doesn't know what to do. So it just has to select everything, and it may just ignore that index, whereas that index may pull it a lot faster. And then because of that, it can also generate a bad query plan. It can tell itself basically the wrong way to get the data that you're looking at, and that'll very likely cause it to be significantly slower or significantly less performant than you want it to be. And the last thing that can happen, really, depending on how you're using that select star, it'll return the columns in the place that they're essentially in the database. And so if somebody inserts a column or changes a name or something like that, you might not realize it, and it might cause errors in your application because you're not specifically saying, this is where this is the column that I want. And so you might get something back that is the wrong thing. And then you may not realize it until it's well too late. One of the next things that I always came across, and I've always you run into, is you only need the top maybe 10 or 20 rows, whatever, of a database. You don't need the entire data set. Again, you're working with a million rows, whatever, all you need is a few. Cold Fusion they've had for years a really nice feature called the max rows attributes of the CF query tag, which is a great feature until you start digging into it. It doesn't really stop. It basically said you won't notice it on the application end. It basically is the JDBC driver will send a command to the SQL server saying, after I get X number of rows, send it back. I don't want anything else. So that's great. Your Cold Fusion page or your application page will respond quickly, but that doesn't necessarily mean that the SQL Server stops, because the SQL Server gets the query and it starts working on the query. JDBC is a totally different layer, and it says, I'm done, but the database itself may continue to go. So you don't know, that may cause some problems there. This is something that may have been fixed on newer versions. I'm still not 100% sure. In some initial testing that I did, based on, I mean, the only information I found was some really old information. There was some articles by Ray Camden and looks like Wacom Van Deeten, I believe, that talked about going over this, but again, they were very old articles. However, when I tested on newer Cold Fusion and newer SQL, it still seemed to send the same queries back to the database that it has. So I believe that the database is still doing the work, and it's not really. Your application is still short-circuiting, but the database may still be doing the work. One other problem that I had, another common, I guess, issue is you want to get the last record that was inserted. So a common pattern that I used to use would be, I would do an insert in one query, and then in a very immediately next query, I might do a select the top one, ordered by the insert date descending, whatever, so that I would get the last record inserted. Again, that works great on a single developer's machine, where the single developer is the only one doing the inserts and the selects, because there is nothing else going to insert between that insert and that select the last inserted record. However, if you're actually in a real production system where you've got multiple users, there very well could be two inserts happening at the same time. And in that very tiny little second, that very tiny little amount of time between the insert and selecting the max record, you still could get some concurrency issues where you're pulling the last inserted record of somebody else's insert. So that's not good. There's better ways to get to that data. Most of the SQL flavors have their own methods that will return that number of the record that you just inserted with inside that single transaction, I guess. But CFML also has inside their CF query tag inside the queries. If you name it a result, you name the result, you can get a generated key out of that, which essentially does the exact same thing. It pulls the metadata of the query, and it'll tell you what was the last key of the last record that was inserted. So that's another way to get at that information. Much better way to get the exact row that you really meant. Another thing that I did, looping over queries. This is something that is very common. I still see a query a lot where you have some loop that has to be done, whatever, and then inside that loop there's a query connection made. And what happens here is you end up basically, again, every time you run a CF query, every time you do anything like that, you're making another connection to the database, which the database connections are very expensive. They take a lot of time, they take a lot of resources, and they're not very nice to your database, because then just has to clean up after itself after it does that. So a better way maybe, instead of looping over a query, a better way maybe just to grab all that data, the data that you need in one spot, and then loop over those results, or possibly build the query to build a single query. You want to minimize the hops to the database as much as you can. Because again, a looping over a query will be very, very expensive. And depending on the number of records, you may just totally crash your system, or you may totally slow down your system, not realize why. And that's also kind of the same thing that's going on when using one query to pull data from another thing that I had, like if I needed the IDs for maybe hierarchical data or some sort of nested data, I would say, okay, here's my outside list of things, and then I need to use that outside list to build an inside list of things that relate to that outside list. Well, that's causing significantly much more connections to your database. Again, that's the same thing as looping over a query. You may be able to do that much better in just a simple join, to get all those informations, and then work through the join of the data to split out things that you need. Which brings us to kind of off to the side, joins. So this is, in my opinion, learning joins is probably one of the most important skills that any person who is working with queries can learn. You will be able to get your data back a lot more reliably. You will get your database will work a lot more efficiently if you can figure out, or if it can figure out, I guess, what exactly you're asking it. And again, single joins are one of the best ways to let the database know exactly what you're asking, and then it knows how to make all those tables talk to each other. Some common types, again, are inner joins, which just they'll give you all the related records between two tables, but only those records. If you do an outer join, it'll give you depending on which way you go, left or right, it'll give you all of the records from one table and then the matching records in the other table, but then no information for the records that cannot be matched. And then if you have full joins, that'll give you basically all of the information from both tables, with nulls for the records that don't match, but then the matched records for the ones that do match. And then another one that we have is cross joins, which they do sometimes serve a purpose, but this is a way to basically, it's every row from table one will be matched up to every row from table two. This is a good way to get your DBA to come talk to you in the middle of the day if you accidentally do a cross join. Say on like a 10 million row table to a 40 million row table. That's quite a lot of records that are being returned. Again, this isn't an inclusive list. There's a bunch of information online about single joins. A real quick, I guess, demonstration, a Venn diagram of what they look like. You get the simple joins, inner joins, outer joins. Shows the left and the rights. You can also do exclusions from the joins that are a very, very good way to run a query instead of doing a where not in or something like that. Now this, again, this is totally my personal view on this situation, but when you work with joins, there's a couple of things that you do, as far as building a query. When you join on a table, you got to pick the columns in the two tables that relate to each other. So like you may join table 1 to table 2 on ID, but then if you have multiple conditions, say you need the records from table 2 that are match on the IDs, but they also match on the products IDs. Or you might also only need the records from table 2 that are related to buyer ID, to a buyer ID. So in my opinion, those kind of things where you actually join those tables are done, it should be done inside the join clauses. Now, when you get all the rest of the query built, then you filter it out for the records that you actually want. And that's, in my opinion, that's where the where clause comes in. So you may join all those things together, but then you only want a specific customer ID. So that's where you would use the where clause. They can be done together. I mean, you could move that in my example there, you could move that buyer ID from table 2 equals 42 into the where clause, and it would still do the same thing. You can move any of those into the where clause, and it still does the same thing. Just conceptually, to me, it's always made more sense to make the data that's being joined together as small as possible. Which also brings me to probably one of my biggest pet peeves is SQL or ANSI 89 joins, which is an older way of doing the joins, but I still see it quite a bit where you don't do an inner join or an outer join or anything like that. You simply list from columns, and then it's a comma delimited list of columns. That works. It's an older way of doing it, but it essentially does what I was talking about earlier about making a big Cartesian product and then filtering things down from that Cartesian product. You'd prefer not to do this if you can. One other reason not to do it is I know that in T-SQL it's been deprecated, so it may go away, hopefully at some point. It would be bad to keep writing it and then see it happen. I know that or see it actually go away. I know that in some upgrades, I know that in upgrade to SQL 2016, SQL Server 2016, you will actually get a warning if you have any when you do a test to see, you actually get a warning if you have any queries that are using those old style joins, because those are deprecated. One other thing to keep for is or to keep an eye out for is that there are some gotchas in just basic SQLing or basic querying. I made a comment yesterday about no lock. It's something that again we had a lot of problems with large queries that were blocking on each other, and our solution was to put no lock on all the queries, because that'll fix it. Sort of. I mean, it definitely made that specific query run faster, because all no lock does is it says nothing will block your query, or the no other locks will block your query. It doesn't do anything for any other queries. We still, even though we did that, it sped things up a little bit, but it really didn't help. It's essentially a dirty read. It can read any other any data in your tables that has not yet been committed, that may be being held by another lock. This may not be what you want, especially if you're trying to read data that are trying to do counts on any data, or doing any sort of aggregation or anything like that, because the numbers aren't really going to be truly accurate, because if you roll a record back, then it's no longer there. So it could lead to phantom reads, where you see something, you react to data that you see, and then you can't repeat it because it's been rolled back in the meantime and it's no longer there. So no lock is really, again, it has its places, but it's not really something. It's not a solution that should be near as common as it is. The next thing that I really I guess another gotcha that you got to watch out for is data type conversions, especially um, implicit conversions that you or implicit conversions that you don't know are happening behind the scenes. And in this situation, one is a number, one is a character. Um, they are convertible to each other, but for other things, like if you're trying to take binary data and turn it into a number, that may not work. Sometimes it can work, but it may not work. Because CFML is the way that it is, because it's a dynamic language, it can lead us to overlook some of these implicit conversions that happen in the back end. They also can, because they have a cost, they can slow your systems down in ways that you didn't expect. Because SQL again, SQL only works on what you tell it, what it knows. So it may try to convert something that it sees and try to bash it into something else. So then you may get results back that technically do match based on its assumption when you didn't really want them. So you got to watch out for those. Especially when you're doing like joins or something like that, or where clauses. You have to be careful what you filter. And then this is a common graphic that you'll probably see that gives a good illustration of what types of data can convert to other types. And again, the most important thing is not just what types can convert, but which ones will implicitly convert. Because those are the ones that will give you surprising results. They may give you unexpected things. If they can't convert or they required implicit conversion, then it's going to probably throw you an error saying you can't convert this to this. Whereas if it does, you may not see what happens. And some of those data types, again, character data types like a char, an inchar, car, whatever. Again, another pronunciation funness. These are probably the most common character types in any application that you have. But they're also the most easily SQL injected, because it's really hard to SQL inject into an integer. It takes a very special formulation of a query to do some of this stuff. But with character, if you're allowing any sort of characters in, then you're allowing any sort of characters in. So you get strangeness that you didn't expect. One thing to keep in mind too, when you're building a database or when you're working with a database, is how big that field is that you're working with. Your database, if you're looking for like a 2-digit state name, there is no need to, or state abbreviation rather, there's no need to specify a car 8000 for it, because that's just space that you'll never need, you'll never use. It doesn't need to be any bigger than your expected data, I guess, and that goes for any data type. If you don't expect to insert over a certain number, then just simply don't do it. Also, the same thing with Unicodes, using Unicodes. If you're not going to be using a Unicode data type, any of the nchar, nvarchar, then don't use them, because they're twice as big, and they have about half the size, because they're multi-byte characters, each character that could be stored in there. So you may not want to do it. And the last another caution that you want to use when you're using those data types is truncation. Basically, if you try to insert uh, a 20 character record into a field that's only designed to have 10, then uh, that'll give you an error. First of all, that it says you can't. However, on the flip side of that, sometimes you can have a 20 character field, but when you query it on the other side, you're not um, you're not giving it, or you're not telling it the right type that it's expecting. So, for instance, like here with when you're creating a table, or you're declaring a variable, um, you the SQL server, my SQL server, or sorry, Microsoft SQL Server will default it to just a one link if you don't specify. Now, again, because these are um, because these uh, widths are specified after that data has already been taken, it's going to shorten uh, that record. As far as the table, if you try to insert something in it, it'll probably, you'll have truncation, it'll throw you warnings. But uh, that last example, it defaults it to a different size. It defaults it to 30. If you don't specify it, you can end up with silent truncation that you don't even really realize is happening. Um, and especially if you're working with like 35 character names, and then all of a sudden you're only getting 30 characters back because you declared, or you cast a variable as a varchar without giving it a width. That's going to be hard to figure out why uh, why it's happening, why you're not getting back the full name, full person's name, or whatever. So definitely make sure that when you specify any type of character data type, you give it a width of what it needs to, and that's the number of bytes that it contains, not necessarily the number of characters. And the non-Unicode, again, the characters are single byte characters, so they are the width. However, with a Unicode type, it may be, those may be multiple byte characters. So that width is only the number of bytes, again, that it can be. So you just want to make sure, be careful with those, especially that you don't end up with accidental truncation. The other thing that I actually came across, and it's something that I never really thought about, I came across this question on Slack a couple of weeks ago. Um, when you're doing something with a where, again, if you're working with a fixed column data set, make sure that you know what that column is, because if you have a character, if you have a column that's 5 characters wide and you give it 3 characters, it may not return any results, or it may miss results that you want. The other thing is that to fix that, you can give it 3 characters, but make sure you pad that result out. Pad it to the left if you need to. The SQL standards actually say that it's the ANSI SQL 92 standard says that when you compare 2 strings, they need to be the same length to compare them. So they will take the shorter string and they will compare it to the larger string, except for with the trailing characters, it'll just cut those trailing characters off because those are fairly irrelevant. Now the leading spaces are not. Those do matter, so those will stay there. However, the trailers won't, unless you're using a like statement. Like statement throws everything into a whole different ballpark. And those trailing spaces will be taken into account. One of the other data types that we had were exact number data types. So integers are fairly common. Again, they're exact numbers. So anytime you do 1 plus 2, it'll always be 3. They're whole numbers. You can coerce them to a decimal, You can convert a decimal to an integer. But again, watch out for truncation or rounding when you do push these things back and forth. Again, also make sure that you store, if database storage is important to you, make sure you use the right type of character type or data type, I guess, for the storage space that you want. If you're working on a small table and you will never have more than 255 records, then give it a tiny int and only use 1 byte rather than giving it an entire int using 4. They cover the same amount of numbers, just in less space. Now, the int is actually a interesting one. It's a very common one. And it's also the reason why we're going to run into an issue with dates here in a little bit, because the numbers that it can go to, it can only store, what is that, 2.1 billion digits, and then it has to reset. But that, again, that's common. Make sure you're using the integers, or make sure you're using the data sizes that you need, data types that you need for the proper size. The next one is decimals are still exact number types. With decimals, you specify decimal with a precision and a scale. The precision is the total number of characters that are available, and then the scale is the total number of digits that are after the decimal point. Again, the numeric and decimal are essentially the same type. There's no difference. With a decimal, again, you can specify, depending on how wide you specify it, it can be different data sizes. So you'd want to watch for that. As far as how many bytes that it would take. And again, with decimals, if you do something like 0.1 plus 0.2, it's still going to equal 0.3 because those are exact numbers. Which brings us to the weird ones, floats and reals. Those numbers are, they solve a different problem, I guess. They're optimized for the way that computers work with binary logic. So they don't represent numbers quite the same as just a base 10 system might. So in this situation, it might be very surprising to see that sometimes if you add 0.1 plus 0.2, it doesn't give you 0.3. It'll give you a really long number of digits with another number at the end. So that ends up being, if you're trying to match those together, that ends up not matching. So working with floats and reals or something, they let you access some very, very large numbers. But if you don't need it, you probably don't give yourself the headache of having to work with floats with non-accurate or non-specific precision numbers. You'd be better off using integers or something like that. However, again, something like floats or reals, they do have their place. Now, my personal favorite data type is a date. These are probably the ones that I hate more than anything because they seem like they should be so simple, but they are beyond simple. There's a lot of misunderstanding about the way the dates actually are. People think that a date is represented, or a date is something like it's a 1/12/2020, but that's not the way that the database actually sees a date. It stores it as a number. It's basically a number of ticks since whatever epoch or day zero that system uses. When you're working with Microsoft products, which includes SQL Server or Microsoft Access or Microsoft Excel, something like that, then the epoch would be January 1st of 1900. But for Unix systems, that date is January 1st of 1970. And then some, they roll all the way back to December 31st of 1969. Again, it'll make you go crazy. The biggest thing is to make sure to please store dates as a data object. Don't try to convert to a string and store a string as a date. Don't try to store an integer as a date or what you think is an interpretation of a date. Store it the way that it's stored as the proper data type, as date. That way you can do any kind of date math that you want on it. It's a little bit easier. And then in my notes on here, I have links to the ISO 8601 date formatting, which is a disambiguation essentially of the proper way to store dates that allows it to be sortable, allows it to be basically no matter where you are, the date is going to be it's going to be the same thing, because if you're in the United States or if you're in somewhere in Europe, you may not see the dates as the same thing. A 1-2 could either be January 2nd or it could be February 1st, depending on where you are. And again, when I was bringing up the ends, this is the other thing that drives me nuts about dates here is that this, if any of you remember Y2K, basically it was computers were going to have a hard time with the year rolling over to 2000. So they a lot of smart people worked really hard to fix it so that dates weren't going to crash on January 1st, 2000. However, we've got another one coming up in January 19th of 2038. Again, with that integer, the dates are stored as 32-bit integers, which we saw earlier runs out after about 2 billion integers. That would equal essentially, since 1/1/1970, we're going to run out of integers on January 19th, the morning of January 19th. So there's going to be a lot of really smart people working on probably converting us up to 64-bit integers by then. Let's hope so. A couple of other things to think about with SQL Server. One of the best things, SQL Server was designed to be a set-based system. It's not designed to work on each row. It's designed to work on a set of rows. And a really good guy, Jeff Moden, years ago coined the term rebar, which stands for row by agonizing row, which is how a lot of people will write a SQL statement to process, and it significantly slows down SQL because it has to do everything that it does on each row, rather than if you're able to write something that gives the SQL process into a big batch, it can batch a lot faster. So that you would prefer to batch rather than rebar. There's also a couple of newer functions in SQL. Well, they're not new, but they're newer. Common table expressions. Those help you build up like essentially a temporary table. Instead of using a subquery, you can build up a temporary table that can be named and reused throughout various parts of the queries. It does have to be at the beginning, and it's usually used with the with hint. So you might have seen those. The window functions, those are a great way to aggregate data inside of a specific window of data. You may not want to group you may want to run a count on a specific block, but your BigQuery, you don't want to group by that block. So you can actually run aggregations on a specific set of data inside your query, and that helps a lot. The other thing to think about too when you're doing comparisons is like between. I'm sure we've all used between, like in a where clause, between something like between 1 and 4, where between is an inclusive in SQL Server. So if you do between 1 and 4, it's going to give you back any records that match 1, 2, 3, and 4, or whatever. However, when you use dates, make sure that you're careful with dates, because if you say, another common thing is to say, I want everything that happened in January, so I want everything from January 1st to February 1st. Well, or January 1st to January 3rd or January 31st. I want those. With dates, if you don't give them a time, they default to midnight of that day. So if you say I want everything between January 1st and January 31st, it's going to default to midnight on January 31st. And so everything that happened on January 31st is going to be excluded. But one thing that I've always found to be better is just to be explicit. If you want something to be, basically, if you didn't know that between was inclusive of like the 4 up there, if you said where y is greater than or equal to 1 and y is less than and equal to 4, you would know specifically that you want to include both 1 and 4. Whereas between, you may not. You'd have to know how between works. So the other thing, you want to be very explicit even with that, but you also wanted to use don't use shortcuts. I know that you can use the y works in SQL or in Cold Fusion. I believe the same thing too. Shortcuts they may not be doing exactly what you think you're doing. You got to make sure you've got the right term, I guess, for whatever date part you're actually after. So a Y doesn't necessarily mean year, or it doesn't mean year in SQL. It's the day of the year. And there is nothing about Y that says this is the day of the year. But if you type out year, you know you want the year from today. So you get 2020. Whereas Y, you might get whatever today is, the number of whatever today is. So I'm running out of time here, so let me wrap up pretty quick. SQL's hard. There's been a lot of things that I've learned since I've started using it. It's a totally different language. It's something that you definitely want to learn more than just the basics to really do what it is that you need to do. It works a lot better than what you may think it does. And the way that I learned it, really just be curious about things. I didn't know I was doing things so bad until I had a report that ran. It literally ran overnight, and we were able to knock it down to about an 8-hour run. But then I was like, okay, we can get it to run 8 hours. Then let's see if we can get it to run even better. We had just hired a new database person, so I handed it to that person. They kept it for about 3 days, and they gave it back to me, and it ran in about 2 seconds. So I was curious as to why. And that's part of the long story of how I ended up where I am. But again, that's barely scratching the surface of everything there is to know about SQL. When it comes to things that you can do on your own, there's a lot of things. There's always the manuals. Microsoft has really good manuals. MySQL has really good manuals. Postgres has really good manuals. All of the SQL servers have really good information. There's so much information. If you want to play with them, you can actually use SQL Fiddle and DB Fiddle are both 2 very good online database applications that I've used. And they let you play with multiple engines, so you can actually see how a query behaves differently in the different engines. The thing to keep in mind about DB Fiddle, though, is because it is UK based, it does use the UK flavoring of dates by default. So just watch that, because you might think that you're trying to figure something out for January 2nd, and you're really pulling everything out for February 1st. One other really great resource that I found is the SQL Murder Mystery. It's just something that a college class put together several years ago that's really great. It lets you basically step through a mystery to query a database to get the data that you want. So that by the end, you can figure out who did what. It's a really good way to learn how to query and get join the data together that you need. Some people to follow. Aaron Bertrand is always really good. Really, any of those people there. Um, and then the Sequel family on Twitter is every bit as great as the community that I found here with the Cold Fusion group. They are very helpful, and you cannot go wrong by following pretty much anybody on there. Always ask questions. They're very friendly. They're very helpful. And then also yesterday, if you saw Charlie Hart's presentation, he mentioned a lot of other good resources to check out to monitor your SQL servers. And again, my last warning, please do not test things in a production database. You will, trust me, you'll definitely do yourself favors by this. So again, sorry I ran a little bit long, but thank you for listening to me. And again, I appreciate it. That's how you can find me if you want to find me. And thank you again to Orders and to everything that they're doing here.